It was today. What molecules enter the process of glycolysis, and what ones leave or what ones are produced in the process of glycolysis? So we'll get like inputs and outputs. So we'll have an inside, things that go into glycolysis, and outside, things that go out of it. And we want to get numbers attached to these as well. So like, what is the molecule, and then how many of them come in to make this process happen? Raiden, I can't tell what you're doing. It doesn't look like an arm raise. So
I was going to raise my hand, then you said numbers, and that's what you did.
Okay. Anthony, you want to start us off?
Okay, so glucose goes in, or C6H12O6.
Okay, so that's an input, sure. And the formula C6H12O6. Good memory. What's another name for glucose, C6H12O6?
Sugar.
Yeah, so sugar goes in, right? That's the start of the process. Raiden?
Oxygen.
No.
Oxygen.
No.
But it occurs with or without oxygen.
Which means, yes, that you're absolutely right about that. It occurs with or without oxygen, which means that it does.
Oxygen goes in sometimes.
Nope. Anthony? Say again.
Can I give it an out?
Yeah, give me an out sign.
You get pyruvic acid, which is C3H6O3.
Okay, and we're looking for numbers too. So how many molecules of pyruvic acid come out?
C3.
No, how many numbers? Like one of them, two of them, three of them, four of them? Two molecules of pyruvic acid, right? Because it's half of a glucose. So you split that in half and you get two of those things. So, yeah, I didn't know either. So we've got an input, we've got an output. What's a molecule that comes into it that collects energy? We're looking for the name of the molecule that come in. Olivia? There's one. So that one doesn't collect energy, but ATP is on the input side. Do you remember how many ATP come into it?
4.
Not 4. 2. Yeah, these are the ones that start the process. They're the ones, that's energy, right, for us. That's energy coming in, and those things are used to break this molecule in half and turn it into pyruvic acid. So 2 ATP come in, and obviously then 2 of something else come out. What's ATP called once it's given its energy up? ADP. Very good. The way, I know I've told you guys this before, but I remember stuff in the most simplistic ways possible, like second grade level. The way I remember which one of these has energy and which one doesn't is that the T stands for tri and the D stands for die, and 3 is more than 2, so this has more energy than this, because this is 3 and that's 2. That's how I remember it. I don't know if that helps you, but that's as simple as I remember it. So these come in, they give their energy to break this thing in half and turn it into pyruvic acid, and as a result turn into ADP. So that's true. Raiden? Nope. We're looking for, it's called a carrier molecule, so we're looking for the name of a carrier molecule. A molecule that comes in and collects energy like water poured into a bucket, kind of. Very, Na, on this side or this side?
Wouldn't that be on the outside?
Yeah, do you remember how many there are? Good job. And then that's the full bucket of energy. Again, it's got, to remember these, I remember it's got more letters than the empty bucket of energy. What's the empty bucket that came in, Anthony? Very good. So 2 NADs. Like that. So we've got ATP coming in, 2 of them, ADP going out. 2 NADs coming in, 2 NADHs going out. And there's one more thing coming in and one more thing going out. And you mentioned the number before because you got confused about how many there were. But you had the number right.
4.
4 what?
I don't know.
He's good with numbers. Letters. Okay, so coming in we've got 4 things that don't have energy or things that do have energy? Don't. Okay, so is that ATP or ADP? Very good. And then coming out we'd have 4 ATP. Right? So, and since we can do like the net thing, do you guys know what net is? Like you've got your gross pay, which is your pay before taxes, and then your net pay, which is your pay after the government sticks their hand in your pocket and takes all the money out of there. So we can do that with here, and we've got a net of 2 ATP, right? Because it took 2 to get it started, but we get 4 out of it, which means we get 2 ATP total. We get 2 of those things in the pyruvic acid. So that's the important stuff from last class. You got to know what comes in and what goes out. So with that, you guys can put your warm-ups away for this. On there, in your interactive notebook, you see that thing that we were just on where I put the score in the front for you? Every time I do one of those, and it's random, like some days I'll score those, some days you kind of get a pass on it. They're worth up to 3 points. And 3 points just means you got the questions done, you got the summary done, and you got the assignment on the other page done. That's what that means. You get scored a second time for that when you turn that in for your test. So when you turned it in for your test, you know, when I collect your interactive notebooks, that page is worth 5 points. So if you got a 3 out of 3 on it the first time, that's going to get added to the 5 out of 5 you'll get the next time for a total of 8 points on that stuff. So if you don't have it done, like maybe you got a 1 out of 3 today or a 0 out of 3, but you get it done the next time for when the test comes, you can still get a 5 out of 5 on that. So you can get a 5, you can still pass that page or pass that assignment with a 5 out of 8, which is all right. But if you had it done on time today and everything was squared away, you can get an 8 out of 8. So really you get 2 scores for that, one now and then one when you turn it in for the test. So if you were out yesterday because you were sick, you look really under the weather too, Thomas. I feel for you, man. Yeah, he's got shorts and like, and then, yeah, I am well aware. I had Thomas last year, I know. So, point I was going to make is if you weren't here yesterday, like Jasmine, Aramis, and Thomas, this is due for you. The next time you come to class, seek me out with it and show me that you got it done, because I'm not going to remember to check off for you 3 people that I've got it. Find it online, watch the video, take the notes, do the stuff, come in with it done. Good enough for you, Aramis? Good enough? Good enough? Braden? No. So, next thing we've got is today what we're going to do. We are going to talk about the Krebs cycle. So if you remember, it starts with glycolysis, and then from glycolysis, it goes to the Krebs cycle. That is where we're picking it up today. So I think that means you're on 11 and 12 in your interactive notebook. Is that right? Okay, would you flip to 12? It's actually mostly going to be like diagrams. And on those diagrams that I'm going to put on the board, you'd want to put whatever notes you have to put in there to help you understand what's going on. Because it is kind of a complex one today as we talk about the Krebs cycle. It's one that involves lots of chemical reactions, some called oxidation. And we, at this level, at the high school, is kind of like go over the processes, what comes in and what goes out, without getting into like the chemistry behind why this happens or how this happens. So it is a little bit complex to remember the different pieces that are occurring here and what order they're occurring in. But that's what we're after today. So most of your notes today are going to be diagrams with little notes that you're going to use to explain, here's what's happening in this part, so you can make sense of your diagrams. Krebs cycle. So we're going to start at the very beginning, and because I've got 2 colored markers, you know it's going to be a good day because I've thought this out. I'm going to use 2 different colors to help understand this process. So that's why the 2 different colors up here. So we shall proceed then, which is French for proceed. Which means we're going to make... Huh? I've got all kinds of languages. So we're going to start with our very first molecule, and I know you guys know the name of it because we've said it multiple times today. This thing. So this is a molecule, the chemical formula for which is, Jackson? No, Aiden? So we're looking for the chemical formula, not the name. Good job. So commit that to memory. You're going to need to know it. So that's one that you got to have in there. That's the name of it, as somebody was going to say, is called glucose. Right? And that's the process we're starting with, is the process of glycolysis, which is what we talked about yesterday. That happens in a specific part of the cell called the cytoplasm, which is outside of the mitochondria, right? It's the goop in the cell. It's where this process happens. And one of the first things that happens is that glucose is split into 2 molecules. Olivia, do you remember the name of the 2 molecules that it's split into? That's all right. Angela? Very good. Yeah, so this thing, I'm going to put some weird angles on here so we can make this work, is split into 2 molecules of pyruvic. And do you remember how many carbons big pyruvic acid is? If you take 6 and split it in half, that would be 3. So it's 2 of them, and that's why I've got it written once and in the circles once, but they're 2 3-carbon molecules called pyruvic acid. And that's where we left off yesterday. This process that occurs here is called glycolysis. We talked about that yesterday. What we're going to pick up with today is what comes next in the chain of events, which is called the Krebs cycle. So that is where we're picking it up today with this diagram. So I'm going to make this a little bit smaller here so that I've got room. So I'm going to have a 3-carbon molecule and a 3-carbon molecule like that, which we know are called pyruvic acid. So that's what the PA stands for right there. What's that? Well, so pyruvic acid is 1 molecule, but there's 2 of them. So there's these 6 total carbons are still there. They're just split in half now. So you took like a 6-foot stick and cut it exactly in the center. Now you've got a 3-foot stick and a 3-foot stick. Okay is different than I got it. So where did I lose? So because it's easy to get lost in this, and if I lose you here, the rest of it's going to be like not happening. Perfect. Yep. Yep, these are both the same thing, same molecule, same design, same everything. They are pyruvic acid. But they're 2 separate molecules. Yeah, so it'd be like taking a stick, breaking it in half, and now you got 2 sticks. Yep, so this was glucose, right? And this is called pyruvic acid. So, yeah, changed the name of it, changed the chemical formula, changed everything about it. That's a weird question that I don't know how to answer. It's called pyruvic acid because it's a different molecule. It's like this is gross, but if we cut you in half, you wouldn't be Annabeth anymore. You'd be like, you'd be like Anna and Beth, not Annabeth, but that's a good one, Aiden. Thank you. Same thing here. It's like if we could put it back together, it'd be called glucose again, but because we've taken it apart, it's called something different. Aramis? These circles? Yeah, each of those circles represents 1 carbon. So we're going to start right there with pyruvic acid and what's going to happen to it. And the first thing that happens to it in this thing, I'm actually going to move this down lower, trying this again here. So move this down to show you what happens. So I've got room to write this in. This is pyruvic acid. It goes through a process which is called oxidation, and that oxidation process does this to these 2 pyruvic acid molecules. It takes this last carbon that's right there, and it cuts it off. So it removes it. That carbon gets given off. How do we, and you may not know that you know this answer, but you do know this answer. How do we give off carbon? Yeah, in the form of, what's the name of that gas is what I'm shooting for. CO2. So this carbon gets given off as a molecule of carbon dioxide. This one gets given off as a molecule of carbon dioxide. So when you breathe out, some of what you breathe out comes from right here. That is what we breathe out, yes. Because when this happens, if you remember back to Physical World with me last year, when you break chemical bonds, energy is released. This happens so we can get the energy that's stored there. Yep, and when it happens, this carbon, because remember these are carbons, right, has to be released, and we release it by hooking it onto oxygen, and you've got carbon dioxide. Right?
What about the other 4?
We're going to get to those. So the next process, if we had 3 carbons in this molecule, and we just took 1 off, how many do we have left? 2, right? So this is going to turn into a 2-carbon molecule, which has a name, and this one too. So these are 2 separate molecules, but I'm continuing them like that because there's 2 sets of them. These things have a name, and their name is acetyl, A-C-E-T-Y-L, coenzyme. That's what the CO stands for, so coenzyme A. That's a name you're going to have to remember, as is pyruvic acid and glucose. So acetyl coenzyme A is the name we're looking for. And it's the same carbons that came from glucose that have been oxidized, and 2 carbons have been given off that you've breathed out. Now we're left with 4 of those original 6 carbons. So does where it comes from make sense? How we got there doing all right? Okay. because these things are going to start into the Krebs cycle for us. So they can't go at the same time because there's two of them. So it'd be like trying to get two people to go down a slide at the same time. You get in trouble with the recess lady or whatever. You can't do that. So these things go one at a time through this cycle. There's only room for one of them at a time. And here is how this cycle starts off. This is why I got a purple pen, so I can do this. So it starts off with a 4-carbon molecule whose name we're not going to worry about. It's something like oxyacylic acid, or its name is difficult for me to pronounce and to read. Let's go.
How did the 2 become 4?
We're going to get there, Raiden. So if you let me do the explaining, I can make this make sense to you. You're about 3 steps ahead here. So these two things are still sitting here, and they are going to join what we call the Krebs cycle here. So I'll show you how this works. So it's going to go one of these at a time, we said, right? So one of these at a time, this acetyl coenzyme A is going to join with this 4-carbon molecule. So if you have a 4-carbon molecule and you stick 2 more carbons on there, how many do you have total? 6. And you would think, sweet, we're back to glucose, right? But it's not that way. It's a little bit different. So this joins with this. We're going to make this be a circle here. That gives us 6 carbons. That looks like that. So we've got a 6-carbon molecule, and even though this was a 6-carbon molecule, this one is arranged differently, and as a result, it's got a different name. Its name is citric. Yeah. Citric acid is the name of it. That's also why the Krebs cycle is sometimes called the citric acid cycle. So when you get to college and you take biology, they may call it the citric acid cycle. Kinda, yeah, essentially. Aramis? This one? I don't know what the formula for it is. We could look it up, but I don't know it off the top of my head. The formula for citric acid? No, it's not. Yeah. So citric acid, and I drew that as I didn't want to draw it. So I wanted to draw it like this. I wanted to go 4 purple ones. 1, 2, 3, 4. And 2 of these guys. 1, 2, like that. Right, so here are these 2 carbons that got bonded onto there. So they're stuck on there now and made a 6-carbon molecule. Annabeth? They're 2, they're on way separate sides of this, so no problems there. Right, as in draw this out and tell me what the things are. If you put glucose way over here, you're going to be in trouble. Yeah. So in this process, right now we've got a 6-carbon molecule called citric acid. What's going to happen is it's going to get recycled. It's going to give off eventually 2 of these carbons, turn back into this 4-carbon molecule and grab 2 of these. But in this process of going from a 6-carbon molecule to a 4-carbon molecule, it's giving off lots of energy. That's where some of your energy comes from, is in this process. So I'll take you through how that happens here. The first thing that happens in this process here is that 6-carbon molecule gives off, it undergoes oxidation and gives off a carbon dioxide. And I did that backwards again. 1, 2, 3, 4. It gives off a carbon dioxide. So one of those, that second carbon that was hooked here, is given off as CO2. And when that happens, we broke a bond, right? The chemical bond that was holding these 2 things together snapped. And the result is energy is released. So on this, we've got energy that comes out of here. What's that? That's correct, yeah. So after that, there's only 5 of those pieces on there. So when that carbon dioxide breaks off, the result, energy is released, we said, right? So what you're going to need to know is what form that energy is released in. And when this happens, when that carbon dioxide breaks off of there, there are 2 little bits of energy that come off. One here is we've got NAD, which is an empty bucket of energy, if you remember, that comes and scoops up some energy and turns into NADH, NAD plus, like that. So that's one thing that happens right there. It releases energy, and it's not energy we can use yet, which is why we're putting it into a bucket. Go ahead, Aiden.
How did you get the
So this is a chemical in your body. If you remember, we called it a carrier molecule the other day. No. So I'll try and. So that NAD is one way that energy is collected there. It's not energy we can use directly yet, but it's like in a bucket that's going to get converted into something that we can use. The other form of energy that comes in right there is in the form of ADP. And if you remember, ADP is an uncharged battery, and it comes and actually collects energy, ATP, which we can use. Right, and that works, but as soon as you make like an issue out of that, that's not going to work. I know, I'm just making it clear, like that is not going to work if it's an issue being there. So we've got two little bits of energy that just came out of there. Doing okay so far? All right. And how many carbon molecule are we down to right now? 5, right? We're at a 5 carbon molecule. We started with 6, gave off 1 carbon, so we're down to 5. The next process that happens is again called oxidation, and that last carbon that you've got right there is given off. So we've got carbon given off again in the form of CO2, or carbon dioxide. So that's the stuff you breathe out. It comes from this oxidation right here of pyruvic acid to acetyl coenzyme A. It comes from the oxidation of citric acid to this 5 carbon molecule whose name is escaping me right now. And then the oxidation of the 5 carbon molecule, the 4 carbon molecule, creates those things. So, again, we've broken another bond, right? And when you break a bond, what is released? Energy. So in this one, a little more energy is released here that we've got to put in there. So in this step, to go from here to here, there's actually 3 things that are released. 3, like, types, 4, I thought. 1, 2, 3 will work. Types of energy that are released. The first one is going to be NAD to NADH. So that's a bucket coming in and collecting energy. The next one's the same thing, NAD to NADH. And the last one is a carrier molecule again, but it's just got a different name. This one is FAD to FADH2. Like that. Here's how I talk to you guys about the simple way I try and remember stuff. The way I remember these is that the empty buckets, which are NAD and FAD, have less energy in them than the full buckets, NADH and FADH2. Why is this happening? Because when you break this bond, so here, I need this in purple. I know. When we break this bond, 1, 2, 3, 4, so we've broken off that last carbon, and when we do that, it releases energy. And this is how our body captures that energy. It says, there's energy. Here's 3 buckets that come in. 3 different types of buckets come in and scoop that energy out. And they're going to carry it to someplace else that we'll use later. Gotcha. That's because of the bond energy, this one. So, and if I could remember back well enough to my college cell biology class, it might be because it's like, if you remember from last year, like there were double bonds, sometimes they're single bonds, and it might have to do with how many electrons are bonding them together. That's what's ringing a bell in my... Is that answer enough for you, Hunter? Yeah. Okay. No. And we have gone from a 6 carbon molecule to a 5 carbon molecule to a 4 carbon molecule. Remember how we said one of these kind of waits for this cycle to go? The other one jumps in at this point and does the process over again. So everything you see here, like carbon dioxide, that's how much comes out of one turn of this cycle. But every glucose molecule causes 2 turns of this cycle. So really, 2 carbon dioxides, 2 NADHs, 2 ATPs, 2 carbon dioxides, 2 NADHs, 2 NADHs, 2 FADHs squared for the total of what we get here. It's double what you see here because this molecule goes through it once and then that molecule goes through it once. And when they do, they're totally used up. And I'll show you. What's that? It does get easier, and you're right, it is kind of confusing, but it will get easier. So if we look at this had how many total carbons in it to start with? 6. I'll show you that this whole thing is used up, is oxidized in this process and released out of your breath. So right here, off of each of these molecules, we lose 1 carbon dioxide, right? But we've got 2 molecules, so we've lost 2 carbon dioxides. Okay, which means we've lost 2 carbons. Here we lose 1 carbon dioxide when one of these goes around once. Here we lose another when one of them goes around once. And then the other one comes in, we lose another, and then finally another. So we started with 6 carbons. After this whole process, those 6 carbons are given off as carbon dioxide, and you're left with this original molecule that you started with, and it just keeps going around. So this is a permanent fixture in this process. And the only things that get added to it are these acetyl coenzyme A's. They come in, bond, and then are oxidized, release energy, and the process just keeps going. Hunter? So things you're going to need to know, it depends on what level you're talking about, right? If you want a level 1 question, it's like how many NADHs are released when one molecule of glucose goes through the Krebs cycle. And you'd count them up, right? Yeah, if you'd want, well, it's more than that, right? So we've got NADH, 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 but it's times 2, so there'd be 6 of them. So a level 2 question would be like, draw and diagram out the process. So it depends on where you want to be, you know what I mean? If that makes sense. Or what would happen if you had a malfunction in your in this molecule and there were only 3 carbons there, and you'd realize like, oh, this process wouldn't work anymore. It just wouldn't go. So things like that it kind of depends on what you want to do for your grade, what kind of stuff you want to remember. I don't know if that's a great answer for you, but that's my answer. So that is the Krebs cycle. That's why we exhale. All the carbon dioxide you breathe out comes from sugar and stuff that your body converts to sugar inside of you and delivers to your cells through your blood. What you eat in, you would think, like I always thought, like what you eat and is waste, you poop out. And that's just kind of the thing. Like if your body doesn't use it, you poop it out. But you actually like breathe out some of the stuff you eat as well, which is kind of weird to think about. And might explain why some people have just absolutely terrible breath. That's funny stuff. Come on, that's a funny one. Get it? Because whatever. Anyway, that's funny. You guys will think about that later and you'll be like, man, St. Clair, he's a funny guy. Yeah, you will. I know it. So in any case, that is the Krebs cycle for your brother. So today, for questions on these things, you need 2 level 1s and 2 level 2 questions. And remember, the answer to your questions, that becomes your summary. That is your summary. So your summary isn't like a summary. It's an answer to those. So let's talk now about what's going to go on that odd-numbered page. So you were on page 10, right? 12. So let's talk about what goes on page 11. And in my head, this is a timeline, but it's a timeline in the form of a tree. So you're welcome for that right off the bat. Hunter. 2 1s, 2 2s. 2 1s, 2 2s. Level 1 questions are like what, right? Level 2 questions are like how or diagram or explain. So level 1 questions are memory questions. Level 2 questions are like explain to me, how does this work, show me that. So let's talk about what's going to go on page 11 for you. And it is going to be a tree. Your tree, the stump of it, this would be the stump of my tree. I was just about to explain that. So the stump of your tree, you want kind of maybe on like the bottom third of your page or so, because the branches we want to take up the top part of your page. This stump is going, or this stem, whatever you want to call it, is going to be labeled Krebs. I believe it's after the fellow who invented it. The other name for it is a citric acid cycle, which is the name of that 6-carbon molecule that goes around. So you've got your stump labeled Krebs cycle. And what we're going to do is kind of like a timeline, which means that the branches you make of this are going to have to come off in like some kind of order. Like you'd have a first branch, and then the next one up would be your second branch and your third branch. So we want the branches to come off in order. And what they're going to do, for example, is describe each step that happens and have a little piece of fruit on the end that's the product of that process that happens. So I'll give you the first branch here. So here's the first, and I know you guys can draw way better branches than mine, so if your branches look like mine, boo on you, because I draw like maybe a kindergartner, which is embarrassing for me, but I'd also like to point out that even though it's embarrassing for me, I'm still doing it in front of you, so like, because that's how much I care. Here's my tree branch. On the end of this tree branch, which ends as a square because it's clearly been cut by a chainsaw, there is an apple. It may look like a bomb from a 1980s video game, but it's also an apple. You don't have to be so critical of my artwork. I really enjoy my artwork. Yeah, but that doesn't mean you get to make fun of it. It makes me feel bad on the inside. You should be giving me warm fuzzies instead of like the... No, so if you let me explain, I'll get to it. So here's what I'd like. In this process, we're going to pick it up with the Krebs cycle, so I can show you here. The first process we're talking about happens right here, where pyruvic acid is converted to acetyl coenzyme A. So on this branch, I want you to describe that process. You can write it below it, beside it, or if you made your branch big enough, you can write it right in there. For me, I'd write something like this. It is pyruvic acid is oxidized, which means it undergoes chemical process. I'm not going to ask you what oxidized means. In fact, we don't even have to use that word. We can use pyruvic acid is converted into, what's the name of the substance it's converted into, Raiden? No, not yet. Acetyl coenzyme A. Is converted into acetyl coenzyme A, which releases carbon dioxide, if you remember, and what's the name of the when pyruvic acid and obviously acetyl coenzyme A. So pyruvic acid is converted into acetyl coenzyme acid, or acetyl coenzyme A, which releases carbon dioxide and creates that acetyl coenzyme A. So that's your timeline part of it. And then that little fruit at the end of it, I'd like you to put there in that little fruit the thing that is made. So in this one, acetyl coenzyme A is made. So your label for your apple or your time bomb that's growing on a tree or whatever you've got there would be acetyl coenzyme A. And then, you'd go up and do your next branch, which might be over here, something like that, and you'd have a little fruit on the end of that, and it's going to be whatever gets produced next, and this thing would describe what's produced next. And then your tree would keep going up, and you'd have another branch like that. And so, as many as it takes you to do that. So that's your goal, and that's what I'll see the next time you guys come in, which is tomorrow.